Let's take a look at this problem that a number of people have asked questions about. We're looking here at topic 7, which is actually chapter 6 in your textbook, dealing with thermochemistry. And now this is a problem involving a calorimeter. Remember, that just means something like a coffee cup calorimeter is what we use in lab. And we measure whatever is going on with the system by the temperature change that's involved in the water that surrounds the system. So this is question 4. And in question 4, a student sets up a calorimetry experiment in which they react some barium metal with hydrochloric acid. Now the first thing I did was write a balanced chemical equation for this reaction because really it would be prudent to determine the limiting reactant in this problem. So we know that if we take a metal and we combine it with an acid, we will make hydrogen gas, and the metal salt, the metal and the negative ion from the acid will be combined, and we balance this equation. Now the problem gives me 9.28 grams of barium. In your problem, you will have some other metal than barium, possibly, or a different amount of barium. And so we know we have 0.0676 moles of barium. Now, how do I get 190 milliliters of hydrochloric acid? How did I get this number? Well, I got that number because I know that the total mass is 200, and I just found this difference and then made a quick estimate of, okay, we've got at least 190 milliliters or 0.19 liters, and it's 6 molar hydrochloric acid, so 6 moles per liter. So I have hydrochloric acid, I have 1.1 moles of HCl. So that's way in excess. I need twice as much of the acid, twice as many moles as I need of barium, and I have much more than that. So let's go on and look at the next part of the problem then. The next part of the problem requires that we calculate the amount of heat that's generated by this reaction. So we take the mass, now that's 200 grams, that's everything in the cup, that's everything in the cup, its mass, times the change in temperature. Well, it went from 18.98 up to 19.02, that's a change of 0.04 degrees Celsius. And we're going to use a specific heat for water, even though this isn't pure water. The problem says it's close enough. So 4.18 joules for every gram of the solution we have, and every degree that the temperature is changing gives us an energy of 33.44 joules that was moved from the chemical reaction out into the surrounding water. Now the change in enthalpy for this would be a negative number, because the system, the chemical reaction, lost energy. But I think the way they've worded this question, they're just wanting to know how much heat is transferred in this reaction. Wish they'd been a little more clear on that. So the rest of the question is very easy. We know how many joules. We know how many joules we have. We know how many moles of barium we have. We know that they're looking for the answer in joules per mole, by the way, and so we do the math and calculate that 495 joules per mole of barium, 495 joules per mole were transferred in this reaction. The delta H would be negative 495. I think the answer they're accepting is 495, plus or minus 3%.